Of statistics part section 1. Frequency distribution. So a frequency distribution is a way to present data in a manageable form. It shows the data values, the number of times the data values occur, aka frequency, and includes relative frequency for the number of times that data occurs as a decimal or a percent. So let's take a look at example 1. I've already drawn the frequency table. So these are letter grades for a sample of students in an algebra course. So you need one column for the grade, and there are 5 different grades, A, B, C, D, and F. And then I have an extra row for the total. The next column is frequency, so we're going to count how many A's there are, how many B's there are, etc. And then relative frequency, I will get to once we have this all filled in. So I'm going to use my highlighter to help keep track of the counting because it's easy to miss one otherwise. So starting with A's, I'm going to go 1, 2, 3. Okay, so I got 3 A's. And if I did miss one, it'll get caught because I'll have some that aren't highlighted. B's, 1, 2, 3, 4, 5. So I did use a different color highlighter because it would be confusing if I didn't. So bring out all your highlighters. You'll need them for this section. C's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 C's. D's, 1, 2, 3. There's only 3 D's. And then the only thing I should have left is F, and that is true. There's 1, 2 F's. Now, I need to total all of those frequencies. So if we add that all up, it's 23. And another way to make sure I haven't missed anything is to count all the data. So I've already done that, and it does add up to, there's 23 pieces of data there. Relative frequency. To find that, you just take the frequency and divide it by the total. And it should be represented with it as a decimal or a percent. So I'm going to do that after I write down all the fraction forms. And the relative frequency should always add up to 1. So 3 divided by 23 is approximately, so I'm using squiggly equals instead of regular equals, because it just indicates to the reader that it's not exactly the number that I'm going to put down, 0.1304. I rounded to 4 decimal places. There were a lot more, but 4 is sufficient. And there's another one with 3 in it, so I can go ahead and put that one in. 5 divided by 23 is 0.2174. Rounded to 4 decimal places. 10 divided by 23 is approximately 0.4348, rounded to 4 decimal places. And 2 divided by 23 is approximately 0.0870, rounded to 4 decimal places. So I checked, and that does add up to 1. So that is our frequency distribution. We have another one for ages. It says 35, but there's actually 37 there if you count them. So I'll fix that on the original, but for now, if yours doesn't say 37, then go ahead and fix it. And then the lowest age was 10 and the highest is 18. So you want to represent all of the ages between and including 10 and 18. So the ages go from 10, 11, 12, 13, 14, 15, 16, 17, 18. And then we have to go through and get the frequency for them. So I'm going to use the highlighter again, highlighting all of my 10s, and there's one here, there's one here. It looks like there's only 2, but by highlighting it, if I missed any, I'm going to catch them at the end. There weren't any 11s, but we still have to have 11 in our table because it would be kind of weird to skip it. So if you should include all of the values between your lowest and highest number. 12, let's see, we got 1, 2, 3, 4, 5, 6. I got 6. So 13, so I'm changing my highlighter color again. 1, 2, 3, 4, 5, 6, 7. Yeah, that's all I see. Again, if I missed any, I will find it. Okay, highlighter. Doing 14 now. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 14s. 15. 1, 2, 3, 4, 5, 6, 7. 16s. 1, 2. Just 2. Let me see. Oh, there's another one. It was hiding on me. There's 3 16s. 17. I only see 1 17 and 1 18. So you know how to find relative frequency now. You just divide each frequency by 37. So I'm just going to give you the values rounded to 4 decimal places. And I already checked that they add up to 1. Of course, if you add all these decimals up to, add all these relative frequencies up that are rounded, it's not going to be exactly 1 because it's rounded. Oh shoot. I hope you guys didn't copy those. My original was out of order, so these are all incorrect. And I accidentally deleted some lines. Sorry about that. I originally didn't notice that the 10 was there. So for 10, it was 0.0541. Hopefully you used a pencil here, because I just totally messed you up. At least I didn't finish making the video before I realized it. Okay. Yeah, so I was saying that if you add up all these decimals, you're probably not getting exactly 1. It might be 0.99 or 1.01. But that's again because you're rounding, but if you actually add up all the fraction form of it, it's exactly 1. All right, classes. So sometimes there's too much variety in the data to just do a frequency table with each data item. So we use classes to make it more manageable. So we have this grade distribution on test scores, and we want to make a frequency distribution with classes for this one. So we want to take the largest grade, which is a 94, and subtract the smallest grade, which is 43. So you get 51. That means that the range of the data is 51. So since we're talking about test grades, The most appropriate thing to do would to group it by like letter grades. So how many A's, B's, C's, D's, and F's were there? So that would be A, B, C, D, F. So that's 5. I want to have 5 different groups. So if you divide 51 by 5, you get 10.2. And then you just make that, turn that into the next whole number. So you want it to be a nice whole number. So each class is going to have a width of 10. So 5 because there's 5 letter grades. All right, so let's get a table made here. So we're going to have the test score, the frequency, and relative frequency. All right, so I know that I'm going to have 5 different groups. That's 3 and 4 and 5. So I didn't leave a whole lot of room for total that I'm going to write over this picture. So the total for this one, there's 40 scores. So it should add up to 40. All right, so my lowest test score is a 43. So I want to go a little bit before that and use a nice number. So we're going to do 40 to 49 as our first class. And you might be thinking, well, hold up, that's only 9 numbers, not 10. When we said our class width was 10, if you count 40 to 49 on your fingers, you will use all 10 digits. I know, it's crazy, but trust me, it works. And then we have 50 to 59, 60 to 69, 70 to 79, 80 to 89. Oh yeah, we have 6, not 5. I miscounted. Okay, so I'm going to put the other row down here. I'm sorry about the stuff in between. Actually, you know what I can do is I can white that out. Use my iPad whiteout. And that'll give me room for my total and my last class. You guys can't easily do that probably. So give yourself enough room. Okay, draw this. And it makes it nice and straight for me, which is lovely. Oh, I don't like that size. 90 to 99 and then total. Okay, good. Now the counting. So grab your highlighter and we want to highlight all of the 40s. So we've got one here. And I just go down row by row. One here and one here. So I counted 3 in the 40 range. And then we do the same for 50s, for 60s, etc. So 50s. And if I miss any, it's okay because I'm going to catch it at the end. One, two, three, four, five, 6. I got 6 in the 50 range. So if you notice that I miss any, don't freak out because I will catch it and I'll fix it. I got 6 in the 60 range. All right, we're in 70s. whole bunch of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 70s. Unless I find more later. All right, 80s. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the only thing I should have left now are the 90s. And this is where if I made a mistake, I would catch it. So 1, 2, 3, 4, 5. I got 5 90s, and by some miracle, I didn't make a mistake. Double check that does add up to 40 though. 18, 30. So I'm going to add it up all right now just to make sure as a precaution. Yes, it does work. And then relative frequency, I'm going to divide 3 by 40. And that's 0.075. 6 divided by 40, 0.15, and we have that twice. 11 divided by 40, 0.275. And I don't even have to round on these because they all come out as nice short decimals. 5 divided by 40 is 0.125. So this would come out to be exactly 1 because I didn't do any rounding when I add up all the relative frequencies.